Okay. Hello everyone, our group will be covering wave energy and ocean thermal energy. Firstly, what is wave energy? It is the energy that waves have within their movement, and we want to harness this energy to generate electricity. Ocean waves are one of the most powerful forces known to man. Even though 75% of the Earth's surface is covered with water, waves are largely an unexplored source of energy. There are two types of waves, namely the onshore wave shown on the left and the offshore wave shown on the right. Waves behave differently on the coastline as compared to offshore. When a wave reaches the coast, the seabed underneath the wave gets shallower and shallower as it nears the shoreline. This causes the wave to rise up from the water and crash over the top of itself, something you've probably seen on most beaches. Fixed devices are attached to the coastline and need the waves to break near them to generate electricity. They work by trapping a column of air inside a concrete chamber that is half submerged in water. As the water moves into the chamber, air inside the chamber is pushed out, passing through a turbine that spins, causing a generator to produce electricity. When the waves retreat from the chamber, it sucks fresh air back into the chamber, generating more electricity. This process repeats with each wave that passes into the chamber. Out in the middle of the ocean, waves move in an up and down motion or swell. You've probably experienced the swell of the waves that occur offshore if you've been on a ferry or ever felt seasick. Floating devices are found offshore and work in an entirely different way to fixed devices. The floating device is made up of large metal tubes that are connected together by hinges. The group of tubes is attached to the seabed using cables to fix the device in one place. As the swell passes underneath the device, one tube will move upward and the tube that is connected to will move downward. This movement is repeated down the tubes as the wave passes underneath. The hinges between the tubes are connected to a pump. This pumps oil through a hydraulic motor as the tubes move, which in turn generates electricity as it spins around. This electricity generated can be taken to land via cables attached to the seabed. The advantages of wave energy is that it is renewable, eco-friendly as there is no emission of greenhouse gases, no damage to land as compared to fossil fuels, massive damage is lost to the land for extracting of energy, easy to predict as it is more consistent than sources dependent on sun or wind, low maintenance cost, and lastly, offshore waves have the potential to generate large amount of energy.
Yay!
The disadvantages of wave energy is that it is expensive to study and research about wave energy, and a lot of money is needed to create the devices that harness the wave energy. Furthermore, it is difficult and costly to design and construct a device that can efficiently capture the wave energy. Offshore wave energy generation can interfere with shipping and wildlife. And lastly, only power plants in towns near the ocean could benefit from it. Now, let us move on to ocean thermal energy. So, what is ocean thermal energy? The sun warms the surface of the ocean, and ocean thermal energy uses the natural ocean thermal gradient, or thermal energy, which is the warmer surface water and the colder deep water to generate renewable energy. Ocean thermal energy conversion uses the ocean's warm surface water with a temperature of around 25 degrees Celsius to vaporize a working fluid, which has a low boiling point such as ammonia. The vapor expands and spins a turbine coupled to a generator to produce electricity. The vapor is then cooled by seawater that has been pumped from the deeper ocean layer where the temperature is about 5 degrees Celsius. That condenses the working fluid back into liquid so it can be reused. This is a continuous electricity generating cycle. The efficiency of the cycle is strongly determined by the temperature differential. The bigger the temperature difference, the higher the efficiency. The technology is therefore viable primarily in equatorial areas where the year-round temperature differential is at least 20 degrees Celsius. The advantages of ocean thermal energy is that it is renewable, environmentally friendly as there is no emission of greenhouse gases, abundant, and widely available, especially tropical waters, and lastly, works day and night with only routine pump maintenance and little ongoing costs. The disadvantages are the large difference between surface of water and deep water is needed for better efficiency. Only advisable to use in tropical area due to the need of constant supply of warm and cold water. Maintenance of the converter is needed. Relatively inefficient. There will be a considerable impact on shorelines which are home to coral reefs and mangroves. And lastly, it requires a safe location from storms and surf. It will be recommended that the harnessing of wave energy should be done in oceans that generally produces large waves throughout the year. Since tidal energy turbines are expensive, it will make more out of the investment to place it in countries like Costa Rica than in Singapore, where the beaches are man-made and only experiences inshore waves. In this century, the demand of energy is very high. Hence, there is a need for supply of energy other than fossil fuels. Ocean energy provides as an alternative source by generating energy and electricity through wave energy and ocean thermal energy. Moreover, the rate of global warming is increasing. Production of energy through ocean lessens pollution. It reduces the production of greenhouse gases through green engineering.